Alright, so in this video I'm going to go over all the questions in the Unit 6 review. We're going to take a Unit 6 quiz on Friday. So just going to jump in, get a little ways, and then we'll stop and move on to the next video. So, number one, find the value of x in the figure below. Well, what I see is a bunch of mid-segments. So I know they're mid-segments because of these markings here, which show that that's the midpoint of BC. These markings show that that's the midpoint of AC, and these markings show that that's the midpoint of AB. So these are all mid-segments. I know the perimeter of the whole big triangle is 96. Okay? So what that means is the perimeter of the small triangle is half of that, or 48. Okay, so I can add up a couple ways of doing this. I'll do 2x plus 3x plus 2 plus 4x plus 1 equals 48. Now, where'd that 48 come from? Half of 2. Okay? So, solve that real quick. I get 9x plus 3 equals 48. Subtract 3. X equals 5. And then find the length of BC. Okay, so if we want to find the BC, the mid-segment that's going with BC is this one right here, the one that's parallel to it. So I'm going to look at 3x plus 2. So 3 times 5 plus 2, that's 15 plus 2, that's 17. That's the length of this right here. So then the length of BC is double that. So 34. Okay. Number 2, also dealing with mid-segments. Explain why EF is congruent to HG. Okay, so EF is the mid-segment, okay, that goes with AC there. Okay, we know that because of the markings. So E is the midpoint of AB, F is the midpoint of CB. HG is also a mid-segment. Again, markings show that H is the midpoint, G is the midpoint, and so since they're mid-segments, we know that EF is equal to 1/2 of AC, right? We know that the length of this is half of the third side. Well then, if we look at this one, that's HG is half of the third side, which is AC. Well, since these are equal to the same thing, the transitive property says that EF is congruent to or equal to HG, since they're equal to the same thing. Okay. 3 through 6, more work with mid-segments here. Now, the next, first one here, number 3, is dealing with the mid-segment of a trapezoid. We haven't talked about that, but if you see that this line right here divides this trapezoid into 2 triangles, you'll see that I can find x by finding this mid-segment here and this mid-segment here and adding them together. So if this is 15, the mid-segment is half of that, so that's 7.5. So this right here would be 7.5. It's half of 15. This mid-segment here is half of 33, so that would be 16.5. So then x would be 7.5 plus 16.5, which is 23, 24. Next one, again, mid-segment. We know that by the markings. Got to look for those first. I know that this times 2 equals the third side. That's probably the easiest way to deal with it, so you don't have to deal with fractions. You could also say half of this equals that, right? So this is half of this. So you might be thinking, well, you should be putting a half here. No, you have to double this side to get this side. So double that side to get the whole side. So 4x minus 14 equals 3x plus 1. X equals 15. And then you can check it to make sure it's right. 2 times 15 is 30. 30 minus 7 is 23. 3 times 15 is 45 plus 1 is 46. And there you go. 23 is half of 46. Okay, finding x over here. We got a lot of mid-segments going on here. A little bit of a confusing picture. So I'm going to just look at that little, not the littlest triangle, but the little triangle here. That's the midpoint, because those are both 5s. That's the midpoint, because those are both 4s. If the midsegment's 3, then this side is 6. Because that's half of this. But now if I look at this point, from here to here is 10, and 10, that's the midpoint of the big triangle here. That's 8, and that's 8. It's the midpoint. So this is a midsegment. X is 12. It's double 6. Okay, same idea here. This is a midsegment for this triangle here. So double x plus 2, I get 2x plus 4. Okay, I double that to get this. Now, a lot of people will go to that third line and think double that. This is not a midsegment for the third for this triangle here. I need to look at the whole triangle. So this is a midsegment for the whole triangle. So I double 2x plus 4, and that'll give me 5x minus 7. So 4x plus 8 equals 5x minus 7. So x add 7, x equals 15, and we are done. Okay. Let's go to the next page here. See, I think we can keep going. This is lesson 2, unit 6, lesson 2. So we're dealing with the bisectors here. Identify the perpendicular bisector. So the bisector is the one that cuts something else in half. So I'm going to look for what got cut in half. Well, I see these markings here. So XZ got cut in half. What did it get cut in half by? WY. So WY is the bisector. Now with that in mind, we can find the length of XY. So XY is right here. The theorem says that a point on the perpendicular bisector, so a point on WY, is equidistant to the segment that it bisected. So it's equidistant to Z and X. So if this is 9, then this has to be 9. What is the length of WZ? W is on the perpendicular bisector, so the distance from W to X is the same as the distance from W to Z, so 7.5. What is the perimeter of WXYZ? Well, just add it all up. That's 15 plus 18, that's 33. Okay? And then the last question is, how much larger is the perimeter of triangle XYZ, so XYZ, to WXZ? So let's find the perimeter of XYZ. Well, to do that, I need to find the length of this, and that's 4, so this is 4. So we got 9 plus 9 plus 8. So 9 plus 9 plus 8, that's, 18 plus 8, 26. WXZ is 8 plus 15, or 7.5 plus 7.5 plus 8. It's 23. So how much larger is the perimeter? It's 3 units larger. Okay. 12 through 14, same idea. In the picture, 3x plus 2 equals 4x minus 3. Explain why. Okay? So, again, you could probably just guess that and be right majority of the time, but you need to understand why. Ki is a perpendicular bisector of Hj. Right? And I know that because K is the midpoint, so that means I goes through the middle, it bisects it, and it's perpendicular. Therefore, comma, Hi is equal to, or congruent to, Ji. Okay? So, what is the length of Ji? Well, we need to find x first, so we just set those equal to each other. So x minus 3 equals to x equals 5. So that's going to be 20 minus 3 is 17. Just make sure 3 times 5 is 15 plus 2 is 17. Okay, what is the length of Ji? It is 17. classify triangle HIJ by its sides if we know the perimeter of triangle HIJ is 50. So that comes into play very nicely here because that's 17, what's left? So 17 plus HJ equals 50. So 34, so HJ is 16. So it's not the same as those. 17, 17, I have two sides that are the same, one that's different. That's an isosceles triangle. Okay, last one for this video. Same lesson. Now we're using angle bisectors instead of perpendicular bisectors. Okay, so since the distance from L to KH, so the distance from L to KH is the same as the distance from L to FH, we can conclude that L is on the angle bisector of the figure. Now, I want to stop and make sure you see that. The distance from L to KH, I know that's the distance because that's perpendicular. The shortest distance between L and that line is the perpendicular segment, so it's that. And I see that that's equal to that, so those two, the distance is the same, therefore L is on the angle bisector. So what is the measure of LHG? So LHG would be 4y plus 8, so I got to find y. Well, it's pretty easy to do if I know that that's the angle bisector. Those two things are equal. So 2y equals 18, y equals 9. So the LHG would be 4 times 9 plus 18, so that's 36 plus 18, which is 54 degrees. What is the measure of KHF? KHF is the whole thing here. So if this is 54, that's also 54. 54 plus 54 would be the whole angle, which is 108. And then the last, well, kind of the last question here. What is the measure of angle JLH? JLH is this angle right up here. Well, that's 90. That's 54. Plus, we'll call that x equals 180. So we just basically have to get x by itself. So 90 plus 54 is 144. Subtract it, you get 36. Okay, HL looks like it will go through point E. Will it? Yes or no, and explain. Okay, it will because of the fact that we know that from point E to KH is congruent to E to FH, and we know that by from E to KH is marked by that right angle, from E to FH is marked by that right angle, so those are equal, therefore it's on the angle bisector, and so the angle bisector is going to continue right through E. Okay. So we'll stop there for this video. The next video we'll finish up